Hello everybody, my name is Amir Bar-Maor, I work in Esri, and today I want to talk about LADM, the Land Administration Domain Model, ISO 19152, and the Parcel Fabric. So if you're into LADM or considering to modernize your land administration software, have a go at it. I'm going to go into depth. So first, for those that don't know what LADM is, as I've said, it's the Land Administration Domain Model, ISO standard 19152 from 2012. There's a new edition that will come out in the next few years that will have new sections, but for now we'll refer to the 2012 edition. It is a conceptual model. It's not a data product specification. It's not a physical implementation. It focuses on the 3 R's, rights, restrictions, and responsibilities. And we'll talk a bit about those. It allows us to talk using the same vocabulary between different countries. And there's 3 packages and 1 sub-package we'll cover soon. And the first edition, there's a new edition, number 2 is expected probably next year. So before we get into terminology, we in Esri use many times the term system of record. We also have a system of insight and system of engagement, but most cadastral systems in the world are part of what we refer to as a system of record. They retain recorded information or representation of the recorded information and managed as such. The 3 R's we just glossed over, rights, restrictions, responsibilities, are the relationship between a person to a piece of land. So it could be a right, could be ownership or a lease. A restriction could be land use code, for example, what you cannot do on that piece of land. And responsibility could be something like clearing fire hazards or clearing a ditch for better water flow and water management. So those are the 3 R's. Another term is profile. The profile is defined as a set of 1 or more base standards, but in our context, usually we talk about country profile, in which a country extends and implements the LADM for their country. So a profile could be how we take LADM and implement it, basically. A source is a document providing a legal so-and-so and facts. So basically making the data defendable, right? In a cadastral system, you want to understand where every feature, a point, a line, a polygon, a parcel, and so on came from. It needs to be defendable. So this is referred to as the source. And you can have 2 types of sources. One is called the spatial source. A spatial source is the source of the spatial unit, which we'll talk about soon. A spatial unit is mostly what we call many times a parcel. And then you can have administrative source, which is the same defendable data just for administrative boundaries, or basic administrative unit as it's called in LADM. And how do we know once we implemented LADM that it is conformant with the standard? Well, there's a set of conformance tests in Annex A that you can go through, and we'll go through them today with the Parcel Fabric to prove that the Parcel Fabric is conformant with LADM. And it's not by coincidence. So before we get into that, let's talk about LADM goals. You can read the standard yourselves, but of course, one is to share the vocabulary between different countries, standardization of information services, and it also says that if you look at high level at a glance, all systems out there in the world always model the relationships between people and land. The standard is extendable or extendable. You can basically make it your own. You can add additional fields and so on. And a few phrases from the standard. It's not to replace existing systems, but rather to provide formal language describing them. Okay, so we're talking about ontology and terminology and how to describe systems. You can also use it to talk about the similarities and differences between those systems. It is a descriptive standard, not a prescriptive standard, so that's important. Another statement is conceptual schema. So don't think you can just implement it immediately. You have to design it in a physical information model. And the implementation in physical information model might have different things you'll have to do when you implement it in a physical information model. the complete model may therefore be implemented through a distributed set of geoinformation systems. So that's another thing important. In real life, when you have a cadastral land administration system, it many times comprises of many systems. You have the document management system. You have the land registration system that describes the owners and the relationship to a parcel. And you have the GIS system that usually retains all the geometry of those parcels. You can, of course, try to model everything in one system, in, let's say, the GIS system, which you can do, but in practicality, those systems are usually distributed, and each one does its own thing, and they are integrated together. LADM has 3 packages and 1 sub-packages. So these are the packages: the party, the administrative, and the special unit, and the sub-package of surveying and representation. What is a party? A party is not going to a party. It's a person or organization. And with a party, you can also talk in terms of a member of a party or a group of parties. So a party is basically could be a company, or it could be a household, a couple that both own a parcel. So they are a party of 2, right? So that's a party. Then you have the administrative entity. It consists 0 to many special units, but I think the homogeneous, it has a homogeneous RRR. So this could be something like maybe school district, for example. Everybody in that area can go to this specific school. They have a homogeneous right. They can only go to that school if they have kids in that area. Or it could be a city boundary. So everybody in that area is part of that city, and whatever that implies for their services and where they pay taxes and so on. So these are the administrative boundaries. Then we talk about spatial units. It's an area or a volume of land, water, or space. So you can see it's very wide definition. It can be many things. In practicality, it's usually the parcel. And a parcel can be called in different ways in different countries. Some call it a lot. Some call it parcella. In the Netherlands, it's perceel. In German, it's a complicated word, etc. So you can see a spatial unit is have wide definition, 2D and 3D, underground, above ground. It could be even air right, if you want. And then you have a sub-package of surveying and representation. It's basically how you describe the spatial unit from a geometry perspective. So you can have a point, a source, and a face. It's all part of how you can define that spatial unit and represent it, the geometry of that unit. Now let's switch over to a parcel fabric. So a parcel fabric, unlike the LADM, is a physical extendable information model for parcels. It's built specifically to maintain parcels. We talk about parcels in also a very wide context. We don't give it a label to call it administrative or spatial unit, but if you wanted to, you could. What we find out is that every customer calls it the way they call it for the last hundreds of years, and that works well in their language, of course. It's a comprehensive framework to managing, editing, and sharing parcel data. You can, the data, once you store it in a parcel fabric, can be edited using services, so web services, service-oriented architecture. That means you can access the data from any type of client. You can support multi-user versioned environment for editing. Extendable and configurable, as we'll see soon. A parcel fabric is a controller. So if you think about a parcel fabric, it has no data. It just controls other simple feature classes, which are here. And you can see here that we'll talk about the structure soon, but the record is the source. Everything is definable because it's always tied to the source. And then we have an additional component that LADM does not cover, which is managing quality of parcels. So we have a few engines we can use to evaluate the quality of the parcels and detect and fix any errors if they occur. And of course, everything is D-enabled, so it works in 2D as well as 3D if needed. So let's see how you can create a parcel fabric, and we'll try to use LADM ontology. So I'll switch to my ArcGIS Pro client here. So let's see where that is. And Here's a project, and you can see here my databases. Those databases could be a file, a mobile, which uses SQLite, but it could also be a connection to a PostgreSQL or Microsoft SQL Server or Oracle. For our purposes, I'm just going to use a local file geodatabase. We can create it in file, and then later always copy it to any type of DBMS that we want to use. I'll call it LADM demo for this purpose. And here you can see we have a new file geodatabase. And the first thing we are going to create is a new feature dataset. This will determine the spatial reference of all the data contained in the cadastral agencies. Let's give it a name called Cadastre for now, but you can give it any name. And you can also specify any spatial reference you want. I'll use the one I currently live in, which is the Dutch RDNU spatial reference, so it's metric. And we have created now a new file geodatabase, feature dataset. So if we expand it, we can see here it's called Cadastre. To create a new Parcel Fabric, we right click on this one and we say New and Parcel Fabric. And we can give it a meaningful name. I'm just going to call this one Parcel Fabric and press Run. So now it creates the Parcel Fabric controller, also points, connection lines that are used for surveying purposes to tie to control points, etc. And also the records feature class, which is the spatial source. So if we wanted to change the terminology now into a LADM terminology, we could rename this, instead of Parcel Fabric records, to maybe Parcel Fabric source or just source, however you want. So you can see I can just change the name of it. You can see that we also created a topology, so this is part of the quality things I was talking about. And also adjustment lines, points, vectors. This is only for customers that use least square adjustment to evaluate the spatial accuracy and improve the spatial accuracy of their data. But this Parcel Fabric has no parcels in it right now, no spatial units. So let's create a new spatial unit, a new parcel type, and I'm going to just go to Manage and say Add Parcel Type. And I'm going to call my new parcel type spatial unit. And you can see I have a checkbox here where I can designate it to be used for administrative boundaries, which is the administrative package. So I'm not going to do that now. I'm just going to go with a spatial unit. And in the Parcel Fabric, for every parcel type, you have two types of entities representing a parcel, a polygon and a line. Okay, so each can have its own schema. Each can be extended on its own. So if I wanted to extend my spatial unit schema, I could easily go to my spatial units, for example, data design, fields. And we're not going to go through everything now, but I'm just going to show you quickly. And let's say I wanted to have another field here, which would say, I don't know, jurisdiction or something like that, or my field value, and I can specify the type of field that you want to have, and then you press Save, and that's, you have a field. You can also specify a domain. A domain is a lookup table or enumeration, as it's called in LADM, and you can specify the values that that enumeration will have. So this will restrict the values to only those specific values. So we're not going to go through this exercise here, but you can see I'm going to discard it and just proceed. And let's say we wanted to add another parcel type for administrative units, so I can go again to Manage, Add Parcel Type, and I'm just going to call it an administrative basic unit. Admin, let's call it unit. Let's just call it admin unit for short, and check this box here and press Run. And it will also create a line and a polygon feature class for that parcel type. Okay, so you can see it's been created. And if we go now to the Parcel Fabric properties, you can go to the Parcel Fabric and you can see the version and so on. What's more interesting for today is that you can see there's two parcel types. One is called spatial unit, another administrative unit. One is not for administrative boundaries, and one is designated as yes. You can also look at the spatial reference and the projection that the data will be set in, and so forth. And this is basically how you would create a parcel fabric and how easily it would be to extend it. We have here, I think, a map of one that was already extended, so we'll just open it. And what we find out that most customers would call their data as they call it. So, but here's an example of a piece of the open data from the Dutch cadastre. And if I were to look at the fields, so we can go to this data design and fields, you could see that it has additional fields that were extended, like the cadastral municipality code and the cadastral something neighborhood, I think, and the section number and so on. So you can see that it can easily be extended. Also, it can use many languages. So this was how we create a new parcel fabric, and a bit about how to extend it. There's more videos if you want to learn how you can easily configure and extend a geodatabase and parcel fabric. And now I'm going to go a bit about mapping the entities to each other. Okay, so LADM calls it spatial unit. We call it a parcel. So it's a single area or water. With the parcel fabric, it's the same as a spatial unit. We have customers that have many parcel types, some for easement, some for taxation, some for ownership, for administrative purposes, and so on. Here's some example: conveyance division, encumbrance tax, parcel, etc. And there's two specializations within LADM. One is for building units, and one is for utility networks, which are legal spaces for utility. And we have customers that do the same. So many of them manage condominium units in different levels, different floors in a building. And we also have utility customers that manage their right-of-ways, if it's a road, or an easement of a utility such as rail or a electric line or water, a telco, etc., using the parcel fabric. So a parcel can be used for many different things, and here you can see a screenshot from what we call the government information model. And you can see under lots and units, there's a unit for condominiums, but there's also a lot. And here you can see the encumbrances, which are easements, and you can see there's a flood easement, and there's just general easement and conservation, and so on. So there's different types of easements. So a parcel and a spatial unit or admin unit are the same. LADM, basic administrative unit, is again the same principle as above, and we have customers that manage this parcel type to manage things like the country or a county or a city or voting districts or DAX, tribe land, and so forth. So you can use it to many different things, and it can contain 0 to many spatial units. So we saw before how to create one. Boundary. So the definition of a boundary, it represents a limit of an entity. In the parcel fabric, like you saw, every parcel type has a set of polygons and lines. The lines are the boundary lines. We also have lines that do not create boundaries, like connection lines. Those are used to tie. Those are surveying tie lines, for example, that do not create a parcel boundary, but can hold measurement information. And we support different types of boundaries. We support true curves, natural boundaries, and two-point lines, of course. And again, we talked about connection lines, and everything, of course, is associated to the source. The way it's called in LADM, it's a spatial source. We call it the record, the legal document from which it came. Usually, it's the record references the legal document. It could be one or many documents that are part of the spatial source, including electronic documents, for example, the survey information. Source and records. So This is, by the way, is probably going to get extended in the next version of LADM to talk about other types of sources, like planning source, right? Different phases in the life cycle of a parcel before it even gets registered. So we will have more types of sources, but the idea is the same. Everything has to be tied to where it came from, and we call it the records because usually the data is recorded in the recorder's office, or registered in the land registration system. Or it could be informal right, but we still want to know who and when it was collected. So that is all part of the record. And in the Parcel Fabric, it actually has a geometry. So it can have a geometry, and it will automatically generate it as things get created and modified to be the footprint of the spatial transaction. The idea here is that you can click on a map and see all the legal transactions that happen in that location. This also is a driver for what we call a parcel lineage, which will not go into detail in this presentation, but in general, when a parcel gets merged or split, it becomes historic and new child parcels get created. Import an LADM schema. So let's say somebody went and implemented an LADM, a schema that is conformant with the LADM terminology. Let's see how that would look in the Parcel Fabric. So I'm going to go to the same location here, and we're going to create a new file database, and we'll call it LADM import. Let's call it LADM import and just create it. So it's been created, and in here I have an XML document which holds all the information of a physical implementation of LADM. So instead of going through the exercise I did before, I would just right click and say import XML workspace document. Now we are going to browse to the XML document, and I'm going to select the XML document and say OK. And import data in schema, no. If there's any data, I'm only interested in the schema, and press run. And it's creating the Parcel Fabric and all. Let's see what it created here, actually. So it's called LADM here. And you can see that there's administrative units, and there's also spatial units. If we right-click to look at the domains, we will see all these enumerations that come with the LADM standard, right? So you can see LA area type, official, non-official, calculated, surveyed, building unit, dimension type, interpolation, level content, etc. So all those enumerations were created automatically just by importing that XML workspace schema. So if you design your own and extend it to be your own, you can also do the reverse. You can just go and say export to a workspace document. So that basically gives you an empty shell of an entire schema that you can model. And you can see here a new button called Generate Schema Report. That will give you a report, a data dictionary of all your tables, classes, relationships in your geodatabase that you can basically put in a nice Word document or PDF for documentation. So that can also be created. We'll not do that today. So let's continue a bit with LADM. If you're still with me, you must be LADM diehards. So thank you. And we're going to move on. So LADM has a thing called version objects. We use a thing called versioning. What is a version object in LADM? A class version object is introduced in LADM to manage and maintain historical data in the database. History requires that inserted and subset data, blah, blah, timestamp, blah, 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 blah. Okay, so in ArcGIS we have this and much more. So every edit can be tracked. Who created it and when? Who modified, last modified, and when. So that's called editor tracking. On top of that, we have archiving. That allows us to move to any historic moment in time and see the data exactly as it was. And on top of that, we have versioning, which allows multiple editors to edit the data in the same time, each in their own private or public version. So we call this principle of isolation. We can isolate one user from the edits performed by another user. And when the time is come and when it has passed, let's say, quality assurance process by the QA person, so you can move the version between one persona to another, you can then reconcile and post the changes. So you can push them and make them official, and from that moment on, that's the official representation of your parcels. You still have the ability, of course, to move back in time. And then on top of everything, we also have the notion of historical parcels. So as you split a parcel, let's say, into 5 child parcels, the original parcel becomes historic. It's still in your database, it's still there, it's just historic. And we can review those parent-child relationships using what we call link chart, which will basically show you visually the parcel lineage, not only what parcel became what other parcels, but also what source, what record was behind that legal transaction. LADM calls it a code list and enumerations. We call it domains. You can see that the Parcel Fabric comes with a list of domains out of the box, but you can extend it like I showed you before. So that's that. Scope. Here's the Parcel Fabric. The whole represents the whole LADM standard. No, it does not. So we don't try to. And the reason is because usually the parties and the 3 Rs are managed in a land registration system, dedicated system that has a lot of other functionality to put all the rights and liens against the property, etc., which we don't cover. And we don't try to cover. We only cover on the special component, the GIS system that represents all the parcel geometry. If you wanted to, you could extend it. And because we are using services, it's actually easier and more sustainable to integrate it to other business systems using service-oriented architecture. But if you wanted to, let me show you an example from a system that we did model. So here we have Ghana, and let me zoom to a place called Accra. So I'll just zoom to a few parcels here. And this is public data that was shared on ArcGIS Online. Let me turn off the administrative parcel called regions. Okay, so now we only see the parcels here. And now that we can see the parcel, let's look at some parcel, and you'll see that there are relationships here. So one relationship is to the record that created this parcel. So this is the special source for this parcel. And you can navigate to its attributes and see how many parcels are included in that, and so on. But you can see that there's also integration to the land ownership database. So I can see that this parcel number 1381 is owned by this person, female, and so on, and this person, male. So that's probably a couple, and registration date was so and so. So as you can see, you can integrate. You can actually either model this in the geodatabase, and here it was actually modeled in the geodatabase. So you can see that there is a land ownership database, and there's also a relationship class that ties the parcel to those owners. So if you wanted to, you could model everything in a geodatabase if you wanted to, but in practicality, if you want a robust land registration system, it's probably going to be a different system. And LADM allows that, to have the implementation of LADM done in multiple separate IT systems. Surveying and representation, we have boundary lines, we talked about them. We have also boundary lines, it's called phase string and boundary phase and special source. So everything is also in the Parcel Fabric. We also, for the records, have a field called record type. You can use it to distinguish between the different sources, right? So since we have one physical table, you can specify this is a special source or this admin source. We have customers using it sometimes to designate the transaction type. Was this a subdivision, a merge, a split, a court order, and so on? But it could also be, like the proposed classes in the next version of LADM, for a life cycle approach. This is a planned parcel, right? And we have customers also using that actually for that reason. They call it preliminary parcel. And many times before they even allow it to get registered, they still need to check that it meets all the requirements for land use and minimal area and maximal area and so on before it gets registered. So LADM, the next version, will probably support that. Other similarities. Both... Oh, we're moving too fast. So, let me move slowly back. Where I think... Did I skip another one by mistake? No, so... It's a bit sluggish. Okay, so... We covered this. We covered this slide. And hopefully it will move to the next slide. Next slide, please. Does that help? Maybe I'll push a button. So both LADM and Parcel Fabric models are flexible. They allow any organization to take them and use it the way they need to and extend it to meet their standards and requirements that will be unique between one organization to the other. LADM sometimes calls it profiles, like we talked. Both models are object-oriented. Both of them have relationships to depict the relationships between the entities. I showed it briefly, but the Parcel Fabric comes with built-in relationships, but you can create additional relationship classes to model other things, like I've done in the example I showed in Ghana, where there's relationship between the owners and the parcel. And there's other ways to model and express relationships. Some could be attribute-based, some could be geometry-based, like topology, right? These parcels must be contained within the other type of parcel, which could be an admin boundary, for example, right? For example, all parcels must be contained within the country boundaries, for example. You could model that if you wanted to. Both standards account for the physical and the legal representation. Okay, so in the Parcel Fabric, we try to be a system of record, which is to be as true as possible to the recorded information. But we know that the parcel depiction in the GIS system can improve over time. For example, we can, if we have new control points, new measurements, we can run least square adjustment to improve the spatial accuracy of the data, and that means that we'll have new improved coordinates for parcel boundaries. So we'll have better notion where that parcel actually is in the real life. That doesn't change, of course, the fact where it is on the ground, just in the representation in the GIS system, and we can account for both representing the legal information and the physical information together. So, of course, if a parcel changes its geometry slightly, we don't change the legal area, it only changes the shapes area, the geometry of the parcel. That's an example. Both support multiple systems of legal descriptions. It could be a legal description that is based on meets and bounds, on measurements of lines. It could be a legal description that is based on coordinates, the coordinate-based cadastre, where the point and the XY, maybe Z coordinates, are the legal definition for a parcel boundary. And it could be used for formal and informal rights, right? That's just a different type of the 3 R's that we talked about. Contents of classes of the LADM and their association. So LADM allows user-defined elements to be added, like attributes, operator associations, new classes, potentially, blah, blah, blah. You can do it when you implement maybe a country profile or a spatial profile. And the first edition is a basic legal profile. Second edition will have extended support for spatial and legal profile. This is talked about in the context of the life cycle of a parcel. And it can be implemented as well. Again, it's all based on user requirements. So each one can use it the way they need it. For example, one might use a profile for evaluation, another one for marine cadastre, another one for spatial planning. So you can see it can get really broad. Other differences. The OID is an object ID, and the Parcel Fabric uses the OID, the object ID from the DBMS, but it also uses a unique identifier, a universal unique identifier. We call it global ID, or it's sometimes called UUID, for both the primary keys and the foreign keys. Okay, so why do we use a universal unique identifier? Is to make sure that we can guarantee uniqueness across databases. Why do we need that? Well, if you take and copy the data from one DBMS from another, it will get assigned new object IDs. So we can always guarantee that the universal unique identifier is maintained unique. But it also allows us to take a piece of the Parcel Fabric and take it offline, right? So we can cut a piece, take it offline to the field, perform edit in the field, disconnected from the network, and then sync back the changes and know that exactly which parcels were created in the mobile device, which one were updated, because we know to match the unique features between the local copy and the master database, let's say. So this allows us to do that, and many more other capabilities. We also, other differences are the Parcel Fabric has built-in quality rules as part of the schema. So we want to guarantee that certain things, like we don't want to see boundary lines self-intersect themselves, right? Or create invalid geometry. So we have those quality rules in place. You can extend it to have additional quality rules, like we don't want to see a boundary line smaller than, or a parcel bigger than or smaller than a certain area, etc. Or outside of the extent of the country, like we see in some countries where points fall in the middle of the ocean. Parcel Fabric also comes with workflows, basic, common parcel workflows that everybody probably has, like merging and splitting and moving a boundary between two parcels, etc. We also have feature-level metadata, which means things like, what is the accuracy of this point? What is the accuracy of this direction or distance, right? So we can start to evaluate the quality of the data and maintain it as metadata on the feature itself. Beyond the feature level metadata, we also have feature class level metadata. We want to know about the polygon feature class, what it is, and explain it. So you can simply look at the metadata of a certain, let's say, spatial unit to understand what that means. Because it can be, like we said, many different things. And we also have explicit parcel lineage. So, like we said before, I'm not going to cover that again. So, if you still survived until now, I applaud you. And now we're going to go, but you're probably an academic. If you reach that point, you're probably in the academy and you really want to know that the Parcel Fabric is supported, is conformant with LADM. And the reason it's conformant is because it was created and designed after the ISO 2012 came to the market. So we used to have an old Parcel Fabric in a product called ArcMap, if you heard about that one. And that one was conformant, but not entirely. And when we designed the new information model of the new Parcel Fabric, we made sure that it is conformant with the abstract test suites. But you probably want me to prove it. So what is the abstract test suite? It is a portion and an annex in the LADM standard that allows you to check that your implementation is conformant with LADM. And there's different levels of conformity, conformant, non-conformant, or not evaluated, okay? And there's different levels of tests we'll see here. So, code list. We call them domains. LADM calls them code list. And you can configure them as you need, and you can support it in different languages, including right to left, if you care so. And you can see here an example and show you before that you can create them here. And you can give them a code and a value. You can remove values that don't pertain to you or the entire domains, and so on. And all LADM code lists start with LA_, so you can see them here. All the Parcel Fabric built-in code lists start with Parcel Fabric underscore, by the way. So, and some of them might be actually overlapping. So if you implement, you can see which one makes more sense to you, like the area type. So, abstract test suite. General, the implementation of the package under test shall contain at least one of the basic classes of LADM. Pass. Parcel Fabric does not cover party and RR. Yes, we know that, but if we talk about the special unit or administrative classes, you can see that we are conformant because we just created one. Next test, please. Identifier, version object. If version object is implemented, too fast, back, one back. It's just moving so slow. Yep. If version object is implemented to ensure that the implementation package under test contains at least one class conformant with the definition of version object and which has all the mandatory attributes and association rules for version object. As we talked about before, we have all of that and much more. The branch versioning that we use is temporal. It allows you to move to any historical moment in time. Any change, whether it's an insert, update, or a delete, are actually never deleted. And they also hold the information about the person that performed them, because all users in this environment must be named users. They have an identity, and we track who they are and when that change occurred. So I think we excel in this test and deliver much more than needed. Administrative BA unit, basic administrative unit, ensure that the implementation package under test contains at least one class conformant with the definition of LA. So organizations have the right that implement Parcel Fabric, and there's hundreds of them, and many of them do elect to implement also an administrative unit. And all the parcel instances has an attribute called name, which is a string, or UID and OID. We also use geodesic topology to define the parcel behavior through topological rules. You can also define rules to prevent parcels from overlapping if you wanted to, for example. And usually the 3 R's are managed in a different system, as we said. So together it is conformant. Party. So it can be implemented, like I showed in the Ghana example, within the geodatabase. But, like we said, in real and many real systems, it's implemented in a dedicated system. However, if you wanted to implement it as part of the Parcel Fabric, you easily could just create another table and a relationship class to depict the 3 R's, or the R's you're interested in. Level 1, identifier for the administrative LA right. Ensure that the implementation package under the test contains at least one class conformant with the definition of class LA right and has mandatory so and so. So again, we don't manage the 3 R's, but if you could put it and associate it to the administrative parcel. Many times it's just kind of insinuated from the name of the administrative boundary. For example, if it's a school district or a tax district, it kind of implies that all the people living within that school district go to that school or under the same tax district would pay the same tax brackets and so on. So it's probably registered in some document somewhere too. Abstract test suite, conformant level 1. Identifier for special unit. Special unit, ensure that the implementation package under one class conformant with the has all the mandatory attributes and association role of the unit type. So when you implement a new parcel type, it comes with a set of attributes, and you can easily extend them further as needed to meet your specific requirements. And we haven't seen one customer that has not extended it by a few fields. Some could be 1 or 2 fields, it could be 20 to 30 fields, and it depends on every organization and how they manage the data. Okay, abstract test suite conformance level 2, we're moving to medium level. Means that all the LADM sub packages is level 2 compliant if level 1 is compliant. So we passed level 1. And now we can move into level 2 set of tests. So identifier, again, has all the mandatory association rules with the source. So now we want the data to be defendable. So as we talked, the Parcel Fabric records feature class can be renamed to source if you wanted to, and it will tie every feature to where it originated from. It will make the data defendable. So what do we have here? Boundary phase string. Ensure that, okay, so this is for the boundary lines. And all the boundary lines are also associated to the special source. They also have a global ID, a OID, and you can extend it as you see fit. And they can be 2-point lines, they could be a natural boundary, they can be a parametric curve, they can even be a parametric spiral curve. So we support that because in many of the countries where the Parcel Fabric is implemented, the parcel is defined using boundary lines. Another test. What are we testing here? The party and a group party. Ensure that the implementation under test contains at least one class conformant with the definition of LA group party. Okay, so we can implement a party and a group party like we saw before. If needed, again, usually this is done outside of the Parcel Fabric. So I wrote can be conformant, so up to the organization. Another test suite, level 2, party member. Okay, so that's Cadastre International implemented LADM in Colombia and I think another country. In that country, it was a simplified information of LADM. You can collect party members. Each one is a person that is tied to a party that has an interest in the land. For example, a couple. So you can configure it to meet it if you wanted to, or decide that it's managed in a third-party system. Abstract trees for conformance level 2, identifier for surveying representation point. Okay, so we have a thing called a point. You can see that we have a Parcel Fabric points. They are the glue between parcels, and it can hold the X, Y, Z attributes of a point. It is a Z-enabled point, so it could live on the surface or in real height if needed. And it has additional values like the XY accuracy, metadata, and Z accuracy. And they're all associated to where they came from as well. So you can also tie them to a domain code list like type of monument, right? The beacon, corner store marker, not marked. So if you needed to, you can tie them to that LADM ontology and domain list. But we have big organizations like the FGDC standard in the US, where there's other types of domains that also pertain to exactly the same thing. So they map easily between each other. Abstract test suite, conformance level 2 again. We are talking here about the restriction for administrative entry, I think. So again, if you manage the 3 R's, you can manage them also any restriction. So can be conformant. What are we talking about here? Surveying representations, special source. So everything has to be tied to the source again. Everything is tied to the record. It doesn't matter if it's a field sketch or a plat or a deed or a title. You can always tie them here. You can have one document specified here. You can have multiple documents specified in part of the record. And we will also update the footprint of the special record when we create the record. Another test suite, special unit group. How to, so this test suite attribute association, okay. So we already have implementations of condominium units of the Parcel Fabric that is for the 2.5D scenarios where you have levels between different floors in a building, or you can model it for entire building if you care to do so. And a future implementation will also allow for 3D object geometry, which is basically irregular geometry types that support advanced 3D cadastre scenarios. So we are conformant on that. And then we are talking about the high level. So we passed the first level, medium level. We passed the medium level. Now we can, and the basic one. Now we can go to the high level. So we combine on the other two, and now we can check the other ones. So boundary face and true implementation under test with at least one class conformant with the definition of LA boundary face, and there's a mandatory attribute associated to that. So all parcel fabric lines are associated to the source using records feature class. Lines are associated to a point using special coincidence to ensure scalability. Okay, so it's not a primary key, foreign key association, because that is a type of relationship that is not scalable. This was one of the problems with the ArcMap implementation of the Parcel Fabric, and maintaining those primary key, foreign key relationship is not performant and not scalable. So now we use special coincidence. So when you move a point, everything will move together. They will maintain their coincidence, but it's an explicit, it's an implicit relationship that uses special proximity. So we are conformant with that. Next slide, please. I'm talking to myself here, and just because the slides move so slow. What are we talking here? Utility network. Yeah. So in LADM, the utility network management is kind of separate. I don't exactly know why it has been separated, but in LADM, but we do have, as we said, customers that move it to manage right-of-ways, utility easements, and so on for different types of utilities: water, electricity, telco, rail, roads, and in the US we sometimes call it encumbrance type. And some of our department, some of our organizations call it easements, and they have many, many different easement types. So you can see here the types that is listed as part of the LADM standard. Okay, what are we talking? Mortgage. No, we don't, again, manage the parties and the restriction. A mortgage is a lien against the property, and shared interest of the bank in your property, of course. And we don't do that. But if you wanted to, you could model your geodatabase to support that as well. So can be conformant. And special unit LA required relationship. Ensure that all implementation under contains at least one class conformant with the definition of LA required relationship. Special unit, mandatory attribute association. Okay, all parcel again associated to the source. So that's by default, whether you want it or not. You can actually delete the relationship class if you don't want to navigate it, but it will still do the right thing for you. So that is done. Test case identifier, responsibility, it's the same thing. So we can also implement responsibilities. And we have customers doing that, I guess, through land use, because land use also represent a restriction as well as responsibility. So you could be conformant here. And I'm not going to go questions because this is not live, so I'm just going to tell you that when in 2010, when we first reviewed LADM, it was not an ISO standard yet then, it was just open for review. It was surprising to see how similar it was to the old Parcel Fabric. And that's not coincidence, they both are designed to manage parcels and cadastral entities. It was taken into account when we designed the new Parcel Fabric, and this is why the new Parcel Fabric that was released in 2019 is conformant with LADM. 2012 version. And of course the business requirement that shape both standards are identical, so they have the same drivers. They are both designed specifically for cadastre or land administration domain. They are purpose built. I like the fact that they're both timeless, So they are agnostic to the technology that where you implement it, or the DBMS flavor and so on, or the type of legal description. They provide a good framework for customers to implement their own information model and meet their business needs. And both standards are designed fit for purpose, and they can be extended and configured to a profile. So many similarities. Without putting additional burden on existing 2D representation. So there's some some now kind of academic discussion in whether 3D is a burden or not. So there's some quotes from the new standards, and the next, we already use 2.5D in many organizations, and they find it very useful to manage and depict their data in 3D using the 2.5D approach. So I'm not going to go about that, and I'll just say from implementation perspective, the XML capability that we saw before, where you can specify an XML workspace, that makes it easier to import and apply to your information model. So if any person wants to create enhance the XML workspace and then share it publicly, that might be useful to others to give them a head start when they implement their own LADM based information model. Other things is, like we said, you can then create it in a file database or a mobile GDB, which uses SQLite, and then just copy and paste it to any DBMS. Postgres, if you like, open source, or SQL Server, if your DBAs are SQL Server DBAs, or Oracle. It's the same schema, and the database does the right thing behind the scenes to just create all the domains and relationship classes and everything that's needed. So it makes implementation really easy that way. Tasks. So when we ship a Parcel Fabric, it also comes with tasks. And some of the tasks are for the actual editing workflows, but some of them are for the administration. So you could also create a task that guides you through the steps needed to create an LADM compliant information model, and also take you maybe through the steps of testing that your implemented LADM Parcel Fabric is conformant with LADM. So you can have both, and it's something I haven't done, but if there's interest, maybe we can do it. And that was it about LADM and the Parcel Fabric. Thank you for surviving this long session. If you have any questions, you can just email me to bar-maor@esri.com, or leave a comment in the community. We have a community, and I'll leave a link below for LADM, so we can collaborate there and share ideas and ask questions and get answers from the experts like Peter van Oosterom and Chrit Lemmen and Eftychia Kalogianni, I think is the name. The last name Bar-Maor is not good, so with the last name Eftychia, apologies. And hopefully we'll soon see the new version of LADM come to life and see how we can easily implement it. Thank you and goodbye.